Thank you very much. And Canadians in the house? Well, there you go. Thank you guys. So mitochondria. I actually think that mitochondria is the most important cellular organelle or component of the cell, and I call it a cellular hard drive or a cellular motherboard. And why is that? Many functions. Number one, ask yourself how many of you now are falling asleep, despite that, we're cracking multiple jokes here. So if you are, your mitochondria is not working right, and you are in lack of energy. So mitochondria is our powerhouse. That's number one. Number two, mitochondria actually controls our genes. So obviously you would like to have healthy mitochondria to convey proper signals into our genes, in our DNA. Then, on top of it, mitochondria is our cellular policeman. Healthy mitochondria recognize the cells that do not belong, that something went wrong, something went wonky with those cells, and will execute those cells. So dysfunctional mitochondria, bad mitochondria, doesn't recognize this. And amongst other mechanisms, it actually participates in calcium regulation, or as well as iron or heme regulation, and many other processes. A very important organelle, and has to be healthy.
Okay, well, usually you hear about mitochondria being only making energy, mostly making energy, ATP for the cell, but it has many other key functions. But you say something, it's the motherboard of the cell. My motherboard in my computer gets sluggish. So what if
my buy a Mac?
Well, it was a Mac, so I switched to a PC. So what happens if your mitochondria, your motherboard, gets sluggish?
So let me ask you a contra question. What did you do to your computer?
Well, first of all, I rebooted it, cleaned it, and voila.
Well, that's exactly what we need to do with the mitochondria. We need to restore, replace, reboot, renew.
Oh, I did only 2 things out of 4, so I better get back to work on my computer. So, reboot, restore, reclaim, repair, everything. Okay, wow. So how do you do that?
There are many ways, and let's start with reduction of oxidative stress. That is number one. We know that mitochondria is a very vulnerable organelle. Some call it, it's like a canary in a coal mine. It's non-protected. And not only it is bound to be harmed by environmental oxidative stress, the one that Dr. Gordon was talking to us about. However, mitochondria is the major cellular producer of free radicals. Because how do we make energy? We utilize oxygen. And we definitely don't utilize oxygen by 100%. In a healthy mitochondria, only 80% of oxygen is utilized. 20% will turn into free radicals. In an unhealthy individual, dysfunctional mitochondria, only 40% of oxygen is utilized. 60% turns into free radicals. So, healthy mitochondria has its own antioxidant mechanisms. So we need to bring it up. So clean oxidative stress, number one, take your NRF2 per tandem. Number two, we need to turn on another protein, which is called NRF1.
Okay.
So would you like me to...
Well, go ahead.
NRF1 is another what is called nuclear transcription factor. Nuclear, meaning that that protein goes into the nucleus and turns on or upregulates over 400 genes, and amongst those genes there are mitochondrial genes, that the genes that turns on production of new, young, vibrant, healthy mitochondria.
So with that said, you are talking about activating the NRF1 pathway to get good, healthy mitochondria. Protein NRF1, with its 5 ingredients, and I'm going to cite them: acetyl-L-carnitine, quercetin, grape extract, CoQ10 and alpha lipoic acid are what is in the protein NRF1. You recognize the name of some of those ingredients. These are building blocks in the mitochondria, but that doesn't make them a NRF1 activator. I've shown the data in the past that they are a NRF1 activator, but more importantly, I want to show a set of data today, the fact that treating muscle cells with protein NRF1 increase the production of mitochondrial protein. So let me bring this slide.
Guys, you do understand that, as Dr. Gordon mentioned, we have 27 peer-reviewed studies on NRF2. And we know, this is awesome, right? And we know that NRF2 science is now on PubMed, over 10,000 studies. However, there are very, very few, if any, studies on NRF1. And to have our new NRF1 pretendant study is incredible. So that new data, I think, is outstanding.
So, and thank you for saying that, but remember, it takes time to publish, so I'm showing you the first set of data, and we are continuing to getting more data, and at some point we'll create a manuscript and get published. But so what you see on the screen is the blue and orange area. So these are muscle cells that were treated with protein NRF1. 8 hours is in blue, 12 hours is in orange. Notice, compared to the vehicle, which is on the left side, you have a significant increase in mitochondrial protein synthesis at 8 hours, and even more at 12 hours. When you have mitochondrial protein synthesis, when that bar goes up, that tells you that you are making more mitochondria, more of those key young mitochondria to help your cells be healthier. So this is the first set of data. So at 8 and 12 hours, protein NRF1 activates the making of new mitochondrial protein in the muscle cells.
And I think this is so critically important because there is a theory of aging which is basically related to the slowing our mitochondria, especially turning 40, the number of mitochondria goes down and the functionality of mitochondria goes down as well. So having the study is so critically important. And the last point of my talk is about the synergies. So Dr. Chevreau just mentioned to you that 5 ingredients in NRF1 per tandem are not NRF1 activators.
Correct.
They are major participants in the functionality of mitochondria. However, 5 of them creates the synergy in this NRF1 upregulation in a proper fashion.
And that's really what all our products, the protein products are about. Putting ingredients that together have better benefit, higher benefit than the sum of each of them. So we've talked about protein